Hey guys, what's up? Eddie Alho here with KISSAnalog.com. Alright, this is going to be really cool because we have a visitor in the lab. And it's right here, hiding behind me. It's Mr. Siglent. So we have a Siglent electronic load. It's a DC1020, is it? Yeah, DC1020X. It's a 200 watt load. I'm going to put the specs right here in the picture below. We'll talk about it as we come over here to the bench as well. These things are invaluable when you're testing power supplies, and I think they're probably great for testing batteries as well. I haven't used it for that yet, but you know what? I use these things all the time at work for testing power supplies. Not the Siglent. This thing I'm sure is a lot more affordable than the stuff I use, but you know what? One of the important things I think in using gear that maybe you don't use every day is how easy it is to use, so you don't have to pull out the manual to learn how to use it. I've been introduced to a lab and had my product to test, and the guys pointed to a bench and said, there you go. I've gone over there and saw electronic loads, scopes and stuff, and no manuals, and luckily I've used enough of them where I've been able to get myself around them. This guy right here, I looked at it for a moment. This thing doesn't, with a little bit of a preview and a little bit of experience on these things, this thing looks very simple, very intuitive. So maybe I don't know everything yet because I haven't spent that much time. I spent just a few minutes here. We're going to spend a few more minutes. I'm going to show you guys what I learned. This is kind of an introduction to this Siglent electronic load. Now, like I said, this is pretty girthy. It's a 200 watt device. This Kunken is a 400 watt. It's nowhere near as girthy as this bad boy. I mean, look at these big knobs too, and look at these. I mean, this guy sure is a lot less than, expensive. That's why I bought it. But, it really is nice to have equipment that you can count on. I'm going to have to do another review on this. I have had a couple of issues I'll talk about, and I think there might be an upgrade I can do to that. I'm going to try to improve on its function. That'll be for another video. This guy, I'm sure it's going to work great. So now, one thing about electronic loads is that when you choose one, for instance, this is DC. The other thing you want to know is how much power, and then it's like, what's the voltage range? You might have a device that puts out 80 volts, and your electronic load will only take 40 or 20. It might do 100 amps, but that doesn't do you any good because you have an 80 volt power supply. So the Kunken and this guy both have two different voltage ranges, and with each voltage range, it's able to take a different current range. So we're going to turn that on because honestly, I don't know what those ranges are until I turn it on, and it'll tell us right here in the display. So let's bring the camera over, take a look. Like I say, it's pretty intuitive, pretty simple. I think you're going to see for yourself. So let's just do this. And by the way, we're going to use the Siglent, my original Siglent SDS1202X, 2-channel scope. This, I think I chose this because it has the larger screen. The X-E of this scope is 1 inch smaller screen, but the FFT is 1 megapoints. Now this FFT on this guy is really good, but it's not quite, it doesn't have the 1 megapoints. But anyway, just a note about this scope, because I know a lot of people have been looking at these Siglent scopes and trying to decide between the X and X-E. I did a video on that, and I'll put a link down below as well, but it's probably an early video. I'm still trying to get better, but anyway, maybe I should do a new one. This scope is a great scope, really enjoy it. Went to the 4-channel with the spectrum and all the stuff that I use on this guy, the Bode plot, that I really use a lot. That's why I use the GW so much, but this guy here, really great scope. FFT is great too. Let's get into this video. Hey guys, so what I've done here is I've propped up I've propped this guy up on this box so I could sit right above the scope. I think that might make it easy for me to get them both on camera. And then over here I have the Hantek CC65. I've got in the ×10 position, okay? And just back here I have a differential probe. So there's a Pintec right back here. It's in the ×20 position, okay? So I'm using a differential probe to plug in to channel 2 right here. And the Hantek current probe is plugged in channel 1. Okay, I'm zoomed in. Let's just take a close look at the scope setup. So channel 1's current probe. So it's DC coupled, bandwidth not limited, 10x position, because I've got that Hantek in the 10x, and I've got it in amps, so units. That's cool. That way our measurements will come out in amps. Okay, channel 2, DC, same stuff, 20x. So that's the difference. And it's in volts. So, alright, I think we're ready to go. Alright, and right now I've got channel 1 reading RMS. Let's get channel 2 up there too. So let's come down, whoops, let's go to measure. And let's go to source 2, type, let's choose RMS. There it is. Okay, check that. Okay, good. Then, alright, I think we're good. We got those 2 RMS measurements. And okay, oh, by the way, I've got this set at 0.5 amp per division, and the volts, 2 volts per division. I'm going to put 12 volts on the screen. Whoops, actually you see it right now. So, yeah. And then you'll see the current triggering, and we'll look to see what kind of voltage response we get, if any. Then right up here is the man of the hour, the visitor of the hour. So it's our Signet SDL 1020X. Let me just get a little bit closer here. Okay, so here, let's just go over some things real quick. Obviously a number pad. Look at the display, it's nice. It gives us volts and current and watts and ohms. So up here it says constant current, because that's where I'm set. You see the LED on, and if I push constant CV for constant voltage, or CR for constant resistance, or CP, constant power. And then I use the arrows to, well, let me see, how do I do that? Okay, so then I think what happens when I want to turn on the load, yep, that's what happens. See the on-off button down here? When I want to turn on the load, now look what happened. Right now I've got about that much current, and it's set for, so it's about 1 watt, 140 ohms, okay? So I'll just turn it off again. And then you can also do the short. So I can hit the short button and it'll just short the output. Okay, but you know, it's the neat thing is once you hit the short, then you still have to turn it on. Now when I do, you can see it's pulling 6 amps. That's all my power supply up there can do. Now, you might have noticed the watts were very low because the voltage drops down because it pulls my power supply down. So yeah, it looks like about a 29 milliohm load. So pretty neat, huh? A lot of neat things you can do. They're just really simple to do. So constant current is a really common setting that I use. And then down here, when you're switching between those, you get a different thing here. See the range right here? It says I range. Current range is 30 amps, or I can hit it and it goes 5 amp range. So might get better resolution at 5 amps if you're just doing small current. I'm going to put it 30. And then voltage range, 36 volts or 150. Now you saw when I first touched it, see when I first touch it, it selects it, then you have to push it again to toggle it. So over here, so I'm going to put this at low voltage, 36, 30 amps. Now current, that's my setting. So it's set for 2 amps right now. I can I can punch in numbers here. So I can say 1, enter. Or I can use this. And see, I'm just got a lot of resolution. I can use these arrows here to move over and say, I want 1.105 amps. So lots of resolution there. And then I said, okay, let's turn it on. Then I reach over, whoops, sorry, got to reach my finger around there. So there you go. There's the wattage, 1.105 amps. Pretty neat. That's about that's equal to about 10.8 ohms. Okay, let me turn it off for a moment. And then you can adjust your slew rate, how fast, how many amps per microsecond it turns on. So you can adjust, you know, that rising or falling edge. You got rising edge here, falling edge here. So lots of control, and like I say, very intuitive, right? Right up here it shows I'm not connected to a network, which I don't know if I have time to get around to trying that out. Okay, so obviously this is a control knob that controls whatever setting you're in. Now here's these big old honking jacks that are really nice. Big old, I like the big old thumb wheels, make it easy. So what I've done is I just put my banana jacks in there and tighten them down. These are 20 amp test leads for anyone that's interested in that. So I'm not going to burn up a set of test leads for this test. I can only pull about 6 amps. And then I've got my differential probes right here. Let's just scan over there. And see them right there? They're just, I just use differential probes just to make sure I didn't have any grounding issues. Since I have them, I just decided to use them. I don't think I would have had a problem putting my scope probe up there because you know what? I have not grounded this. You know what? I'll ohm test this when we're done. Got to remember to do that just to see if these are floating inputs. I don't know if they are, but since I imagine, I almost want to think this is, but not sure. Anyway, okay, so that's pretty neat, right? So when I click on that setting, it's just going to instantly apply a load, and I can change the current and sit there and just apply loads. If you don't know a current and you're thinking resistance, then you just put constant resistance and you just change how many ohms. So see, now here's my ohm range, and it's 30 milliohms to 10 k ohms. And then there's how you adjust that. Right now it's set at 1 ohm. So yeah, so you know, you can sit there, go 1.001 ohms. That seems like a lot of resolution. Let's give that a try. Yeah, look at that. That is nuts. That is some pretty serious resolution. Okay, now let me show you something else, and then I'm going to go to the scope and look at the scope. Let's get something kind of interesting going on. See this dynamic thing? So I hit shift, go dynamic, and then look at this. There's my constant current, so I can change what function I want. You know, constant power, resistance, or voltage. But look at this mode button. That's what I think is interesting. Continuous, see those pulses? And it defines them. It tells you what A level and B level is, the width, A and B width. So you can sit there and totally control that. But check this out. If I go to pulse, and then I have to hit enter, and then it shows me just a single pulse. Or what if I go to toggle, and then I hit enter, and then it's just a little bit different setup, but pretty similar to the other one. Okay, let's go back to continuous, because that's one I want to use right now. That I think is pretty neat. Okay, enter that. So look at this. I can go from 1 amp to 2 amps and sit there and toggle between. So let's see how you do that. I'm at 30 amp range, 36 volt range. Hit the next page. Okay, there's A level right there, 1 amp. And let's change B to 3 amps. Okay, that might make it a little bit more interesting. Then I'm going to just leave this where it is. It's 2 seconds for A, which is the off time. That's where it'll be at 1 amp. And B is 2 seconds where it'll be at 3 amps. See what's on page 3. Okay, here's slew rate control. Okay, let's go ahead and just turn it on. And yeah, look at the readings there. So it's showing my wattage as it's toggling, 35.5 to 12 watts basically. And it's showing the volts and current right here. That's really cool. Now look how it's changing my voltage a little bit. So I'm dropping a little bit across the test leads, right? Okay, let's go down and look at the scope. All right, so there we go. You can see it pulsing. Let me bring the current down a little bit. There we go. And look at the voltage. You can see that nub, right? So let me just show you something with voltage. We're going to go back to channel 2. And we're going to go AC coupled. Whoops, I turned it off. And we're going to go AC coupled. And I'll push the button, bring it up in the center. And I'm going to change the, let's see, where am I? Channel 2 to volts per division. Let's go to 40 millivolts per division. Well, okay, that's a little too close, I guess. 100 millivolts per division. Well, see that spike right there? There we go. Now you can kind of see it maybe. So here, I'm going to stop it, and then we're going to zoom in. Oh, okay, here, I went, see the memory depth? I went to acquire, and see this down here, memory depth 700K. Okay, we got to quit this. Okay, let's go to memory depth. Look at that. I got lots more memory. Okay, so I'm in roll mode, so I can't get as much memory as I think I want. So let's go a little bit faster roll. And let's see if we got the memory yet. Not yet. Oh, you know what I have to do? Sorry. I just have to take it out of roll mode. Okay, bring my trigger up, so trigger, there we go. So it's out of roll mode. Now it's just going to update every time it gets a trigger. Okay, so now let me go ahead, and I've got 7 meg for each channel, okay, because I got 2 channels turned on. So that's good deep memory, I think. Okay, I'm going to freeze it, and let's go zoom in. Okay, let me zoom in here so you can see the screen. Okay, I'm going to hit the zoom function here, and see that sliver right there? Let's widen that out a little bit so I can, well actually what I want to see is I want to see this purple, but you know what? Let's turn off the zoom. Okay, it's a negative spike there. See the positive one over here? That's, okay, let's open that up so it's easier to scroll across. And then we'll scroll over to a positive spike. There we go. And if I put it right in the center of the screen here, then I can zoom a lot easier. It'll stay put. Because when I expand, it'll expand around the center of the screen. See how this gets narrow, the zoom function? There we go. There's that pulse. So there you go. Wow. So that's kind of interesting, right? It has this little pulse, then the voltage kind of recovers, and then it regulates again. But there is a little bit of a pulse, and then this kind of recovery period. Pretty interesting stuff. So that's why we use the dynamic load, to see what our power supplies do. Hey guys, so what do you think? Pretty neat, huh? Right? Replaces a bunch of resistors, and you know where I used to use resistors, I'll tell you what, here's one dynamic load. I'd use 2 resistors, I'd put both resistors connected and use banana jacks and disconnect and connect one of the resistors so I could go from one load to another load, or disconnect both of them, put them in. So yeah, that's another way to do a dynamic load with a bunch of resistors. But if you got one of these guys, it really makes life easy. So, hey, you know what we're going to do? Oh, by the way, if you like the video, give me a thumbs up. That helps the videos a lot, guys. And subscribe if you haven't done so. And I want to thank the Patreons. Appreciate all your support. And by the way, I want to make sure I mention that this was a loaner, okay? So, Signet sent this to me as a loaner. I got to return it. But I'm going to do one more video, okay? And I'm going to do another, I was thinking maybe 2 more videos, but I'm going to do one more video on a switching power supply. Maybe I'll do a couple of switching power supplies. And what I want to do is I want to show you how a switching power supply reacts. I might need to test a couple of them to see what kind of reactions we get, okay? And you can see the value of a dynamic load, or just electronic load, just steady state, just being able to change the current up and down slowly, or you know, at any value you want to versus having to get a bunch of resistors. But pretty cool, right? Okay, hey, thanks for watching, and thumbs up. Hey, we'll see you next time.